a $20 PVC pipe, split in half, bolted to a salvaged motor. It generates direct current, day and night. It requires a 7 miles per hour wind. Solar panels halt electron excitation at sunset. Lithium-ion batteries cost $15,000. They suffer a 20% thermodynamic degradation within 7 years. The rotor architecture has been proven for exactly 1 century. Yet this mechanism appears on 0 federal rebate ledgers. It is a PVC Savonius turbine. You will observe its physical properties. You will observe its mechanical functions. You will observe the assembly parameters. The average American household currently expends $150 per month for electrical current. That metric has increased by 16% within 5 years. The centralized utility dictates the cost. Attempting to detach from this grid prompts a uniform commercial directive: procure photovoltaic arrays, procure lithium storage cells, integrate the system via an inversion mechanism, regulate the charge sequence. The financial probability remains highly variable. A residential solar apparatus with chemical storage requires an acquisition cost between $15,000 and $30,000. Installation parameters are included. The photovoltaic cells degrade structurally at 0.5% annually. The lithium cells experience a 20% electrochemical capacity deficit in 7 years. Net metering introduces external control. The utility modifies the buyback rate unilaterally. Multiple states have executed this exact fiscal shift. Tens of thousands of dollars are allocated. The hardware enters a state of persistent thermodynamic decay the moment the circuit closes. Atmospheric occlusion is entirely omitted from the standard discourse. A dense stratocumulus cloud cover in February ignores a $20,000 silicon array. The photon stream is physically blocked. The chemical storage depletes. The localized voltage drops. The mechanical backup generator initiates combustion. You are combusting refined diesel. It supplements an electrical architecture designed explicitly to eliminate fuel dependence. The atmospheric pressure differentials continue. The wind maintains velocity at night. It maintains velocity in winter. The kinetic transfer peaks during cyclonic storms. This coincides exactly with maximum electrical demand. The apparatus required to capture this kinetic force consists of standardized polymers. They are located in the plumbing aisle of a standard hardware store. 1 trip, 1 afternoon operating a jigsaw. The result is a mechanical structure. It induces electron flow every time the local atmosphere shifts. This data remains externally suppressed. The utility corporation does not disclose it. The photovoltaic installer does not disclose it. The federal rebate administrators do not disclose it. A rigid structural hierarchy mandates this invisibility. The financial incentive architecture will become mathematically transparent once the mechanism is understood. The energy conversion sequence must be defined. A curved polymer intersects atmospheric flow. It induces an electrical current. The underlying physical principle predates modern commercial energy grids. The fluid dynamics are strictly elementary. Aerodynamic flow impacts a curved barrier. The drag coefficient on the concave geometry significantly exceeds the resistance on the convex geometry. This differential in drag force forces a rotational vector. A bisected PVC pipe represents an optimal aerodynamic curve. 2 bisected sections are secured vertically. They align on a central axis in a shaped geometric configuration. Engineers define this as a Savonius rotor. Atmospheric pressure impacts the open concavity of the primary blade. The identical airflow deflects across the convex exterior of the secondary blade. A net rotational torque is generated. The central axis spins. The shaft locks into a permanent magnet motor. The motor translates kinetic rotation directly into direct current. That is the entire mechanical sequence. It requires no planetary gearbox. It requires no localized inversion hardware. It requires no variable pitch control. It requires no yaw orientation motor. A vertical axis turbine intercepts kinetic airflow from any 360-degree vector. Compare that to a commercial horizontal axis turbine. It demands continuous orientation correction. It requires aerodynamic tail fins. It requires electronic yaw drives to maintain optimal wind alignment. The Savonius structural architecture eradicates this mechanical vulnerability entirely. The physics dictate a specific operational compromise. A Savonius rotor operates at a lower theoretical efficiency threshold than an airfoil propeller. The maximum power coefficient for the Savonius configuration caps at roughly 15%. A calibrated horizontal axis turbine approaches 40% efficiency. The comparative metric is structurally flawed. It ignores localized atmospheric reality. The Savonius overcomes static friction at 5 miles per hour. A standard horizontal axis residential turbine requires a minimum 8 to 10 miles per hour velocity. It needs this threshold simply to initiate rotation. Suburban environments generate low, chaotic wind turbulence. Under these exact parameters, the Savonius rotates. The horizontal turbine remains completely stationary. The true metric is the cost per watt of sustained annual production. The Savonius dominates the mathematical output. It simply records more rotational hours. The fluid dynamic drag coefficient of the concave surface measures between 1.5 and 1. The convex surface registers a coefficient of 0.2 to 0. The aerodynamic ratio stands at 3 to 1. This mathematical imbalance forces the rotation. Expanding the polymer diameter increases the active surface area. Increased surface area linearly multiplies the applied torque. An 8-inch diameter PVC cylinder, bisected longitudinally. It yields 2 active blades. Each maintains a chord width of exactly 4 inches. This surface area dictates the threshold for meaningful electron excitation in a 15 miles per hour wind stream. An architectural modification optimizes the output. 2 distinct blade sets are stacked vertically. They are locked at exactly 90 degrees to each other on a singular axis. This geometric shift eradicates the aerodynamic dead spot. The dead spot manifests when a single blade set sits entirely edge-on to the incoming pressure wave. This staggered geometry is a 2-stage Savonius. It regulates the torque curve. The electromagnetic generator never stalls during a rotational cycle. The mechanical equivalent is a 2-cylinder combustion engine. One cylinder enters the dead stroke. The secondary cylinder detonates. The rotational axis never ceases. A fundamental principle of electromagnetism remains widely unrecognized. The permanent magnet motor, extracted from a discarded treadmill, operates as a functional generator. A direct current motor utilizing permanent magnets is entirely bidirectional. Mechanical rotation of the shaft induces a voltage output. Increased rotational velocity results in a linear escalation of voltage. A standard 260-volt treadmill motor dictates a strict conversion ratio. It generates 1 volt of electrical potential for every 25 revolutions per minute. A moderate atmospheric flow induces 300 revolutions per minute. The motor outputs exactly 12 volts. This aligns perfectly with the electrochemical requirements of a 12-volt battery storage bank. Specialized generation hardware is mathematically unnecessary. Custom copper coil windings are unnecessary. Rare earth magnet arrays are unnecessary. The localized thrift store houses the treadmill. The treadmill houses the generator. The physics have remained dormant. The kinetic transfer sequence is absolute. It is direct drive. No gear reduction. No rubber drive belts. No transmission hardware. The PVC polymer rotates the central axis. The axis forces the internal motor rotation. The motor forces a direct current through a conductive copper wire. The electrons flow to the chemical battery. They pass through a singular blocking diode. The semiconductor component requires an acquisition cost of $2. The diode is a unidirectional gate. It prevents the battery from discharging backward. It prevents the motor from spinning as a fan when the wind velocity hits 0. The electrical schematic is finalized. Polymer pipe, magnetic motor, semiconductor diode, copper wire, lead-acid battery. The simplicity of this system triggers biological skepticism. It is scientifically unwarranted. A Finnish engineer named Sigurd Johannes Savonius staked his professional existence on this exact fluid dynamic principle. Savonius was born in 1064. His origin was Hämeenlinna, Finland. His academic training was in structural architecture. His solitary objective was the mechanical capture of kinetic wind energy via maximum structural simplification. In 1922, he fabricated the primary iteration of the modern rotor. He executed field trials on Finnish lakes. He mounted the apparatus to small aquatic rowing vessels. He documented the generation of measurable rotational torque. By 1926, legal patents were secured. Finland, France, Austria, Britain, Denmark. In 1929, the Finnish Academy of Science published his comprehensive data. The paper mapped the precise aerodynamic performance of the shape geometry. He tested it across dozens of chaotic wind velocities. The underlying aerodynamic theory was not even a modern discovery. Bishop Fausto Veranzio documented vertical axis wind structures utilizing curved blades in 1616. The text was Machinae Novae. The fundamental fluid dynamics have been mapped for over 400 years. Savonius merely proved the scalability of the physics. He utilized low-cost materials. He operated in variable atmospheric conditions. The global industrial complex subsequently pivoted. They adopted airfoil propeller designs. The paper efficiency was mathematically superior. The manufacturing complexity and capital requirements were exponentially higher. The United States Department of Energy maintains a digital PDF schematic. The file is designated Building the Basic PVC Wind Turbine. It explicitly targets academic institutions. The National Renewable Energy Laboratory subjected vertical axis turbines to exhaustive physical stress tests. This occurred during the 1970s global energy deficit. Their data confirmed an absolute structural truth. Savonius rotors rank among the most structurally resilient low-speed kinetic capture machines in recorded history. The chronological context requires a specific visual baseline. The dominant modern application of the Savonius geometry is ubiquitous. Human visual processing filters it out constantly. The rotating ventilation caps on commercial vans. The caps on transit buses. The caps on industrial warehouses. They are Savonius rotors. Anton Flettner was a German aerospace engineer. He modified the aerodynamic design in the 1920s for atmospheric extraction. Every commercial transit truck equipped with a rotating roof vent operates a Savonius turbine. The aerodynamic reliability is undisputed. It rotates above the asphalt on every American highway. Society does not classify it as a kinetic wind turbine. It is not coupled to an electromagnetic generator. It is merely displacing local oxygen. The structural geometry remains identical. The fluid dynamics remain identical. The sole variable is the mechanical load on the central axis. Couple the axis to a fan blade. It ventilates a structure. Couple the axis to a magnetic motor. It generates raw electrical power. The scientific literature is established. The mechanical engineering is absolute. The localized material acquisition costs precisely $25. This introduces physical proof. 2 engineers isolated themselves in rural New Mexico in 2004. They required electrical current. Commercial generation hardware exceeded their financial parameters. The geographic distance negated physical grid connection. They engineered a mechanism. They designated it the Chispito wind generator. The aerodynamic blades were a bisected 8-inch PVC sewer pipe. The electromagnetic generator was a permanent magnet DC motor extracted from a discarded treadmill. The aerodynamic tail vane was scrap sheet metal stripped from a washing machine chassis. The primary prototype cost exactly $50. The machine outputs exactly 100 watts in a 30-mile wind vector. The 12-volt chemical charge sequence initiates at a 7 miles per hour atmospheric flow. 2 humans can assemble the architecture in 180 minutes. It requires a jigsaw. It requires a drill. It requires a wrench. The structural schematics were uploaded to a digital server at zero cost. Print magazines replicated the parameters in 2006. The physical assembly was replicated on national television networks 36 months later. The digital schematics migrated to open-source servers. Global operators logged hundreds of successful mechanical verifications. The architectural scale was subsequently expanded. A 1,000-watt iteration was engineered. It maintained the PVC polymer blades and salvaged magnetic motors. An entire isolated structural footprint was energized using a networked array of these specific mechanisms. The kinetic input charged a localized electrochemical battery bank. The thermal regulation and electrical sustainment of isolated structures is fully documented. It contains full structural schematics. It contains exact material acquisitions. It contains the raw mathematical outputs the industry suppresses. The thermodynamic deficit can be mitigated today. A mechanical operator in Germany verified a vertical axis PVC architecture utilizing a bicycle hub dynamo as the primary generator. 8 polymer blades were bisected from 4-inch PVC drainage pipe. The localized material acquisition cost under €40. An atmospheric velocity of 20 miles per hour induced a continuous output of 1 watt. This provides sufficient electrical potential to slowly charge a chemical cell. It provides sufficient current to illuminate a light-emitting diode indefinitely. This wattage appears statistically insignificant. It is not insignificant. The entire physical apparatus was synthesized from discarded components inside a wooden shed. A localized collective verified a modified aerodynamic architecture. They integrated a larger 20-amp treadmill motor acquired digitally for exactly $10. They bisected 36-inch aerodynamic blades from PVC polymer. They secured the rotational axis to a dolly bearing. They verified the electrical output at 7 amps during a 30 milliampere wind event. The mathematical translation is 84 watts at 12 volts. This sustained electrical potential maintains a deep-cycle lead-acid battery at maximum chemical capacity. The geographic location requires only moderate kinetic airflow. 0 operators possessed formal engineering credentials. They possessed polymer pipe. They possessed a magnetic motor. They possessed 48 hours. The Savonius structural geometry dictates the baseline for localized electrification in developing geographic zones. Isolated populations in sub-Saharan Africa utilize bisected steel oil drums. They weld the steel to a vertical axis. The rotational torque pumps subterranean water. The electrical conversion charges lithium-ion cellular batteries. The fluid dynamics are strictly identical to the PVC configuration. The mass of the construction material simply increases. Installation matrices documented in Nepal deployed Savonius rotors constructed from localized scrap sheet metal. The kinetic torque crushed agricultural grain. The electromagnetic conversion powered localized illumination grids in geographically isolated sectors. The material acquisition cost per unit registered under $15. This financial metric is less than a 30-day supply of combustible kerosene for one solitary lamp. The Savonius mechanism operates through the absolute elimination of precision machining. 0 components require microscopic tolerance. 0 components require a sterilized manufacturing environment. Sever a curve. Secure a bolt. The electromagnetic generator produces physical current. The mechanical design is verified for exactly 1 century. The acquisition cost undercuts a standard fuel purchase. A human with standard tools can execute the assembly. Yet, global adoption registers at near 0. The barrier is not a technical failure. The barrier is a structural cage. Analyze municipal zoning. The vast majority of United States residential zoning codes restrict structural elevation to 35 feet. This legal parameter governs all objects anchored within the property boundary. A kinetic wind mechanism requires elevation. Elevation grants access to linear, unobstructed fluid dynamics. A 35-foot elevation traps the rotor in a chaotic turbulence zone. The turbulence is generated by the primary structure. It is generated by adjacent structures. It is generated by biological growth. It is generated by wooden perimeters. The Department of Energy published a small wind parameter guide. The federal text admits elevation is the critical variable. The text confirms municipal zoning codes mathematically negate the installation of functional residential turbines. A legal variance is structurally required. Extracting a variance requires municipal hearings. It requires capital fees. It requires legal representation. It requires systemic chronological delay. An operator applied for a structural permit in Massachusetts in 2001. He intended to mount a micro-turbine on agricultural land. The municipal permit was issued. 90 days passed. The hardware installation was incomplete. The municipality unilaterally revoked the authorization. Adjacent property owners issued verbal objections. It required 13 months of bureaucratic hearings. It required thousands of dollars in legal capital to force the reissue. This is categorized as a bureaucratic failure. It is not a bureaucratic failure. It is the physical defense of a commercial sequence. It does not ban kinetic energy explicitly. It injects terminal financial and chronological friction. The human operator surrenders. Then the homeowners association engages. The municipal zoning board authorizes the structure. The HOA immediately overrides the legal decree. State-level covenants and deed restrictions grant these localized associations absolute authority. They control all visual parameters accessible from the public asphalt. A fraction of states enforce solar access legislation. This extends fractional legal defense to kinetic wind capture. These state mandates do not shatter private deed covenants. California operates within this exact legal framework. The legal protections remain structurally insignificant. The final variable locks the grid. The federal investment tax credit dictates the market. This fiscal mechanism renders photovoltaic arrays financially plausible. The credit applies exclusively to solar systems. A PVC kinetic turbine is strictly excluded. This is not because it fails to induce electron flow. It mathematically induces flow. It is excluded because it violates the specific linguistic definition hard-coded into the federal tax ledger. The federal incentive architecture was constructed to subsidize silicon panels. Every mechanical alternative is legally invisible. Zero commercial installers will advise the construction of a $50 polymer turbine. Their financial commission requires the liquidation of a $25,000 silicon array. Zero centralized utility rebates will subsidize a mechanism synthesized in a residential garage. Zero real estate appraisers will calculate asset value for a polymer pipe and a magnetic motor secured to a steel post. The systemic grid is not suppressing this physics because it failed. It suppresses it because the financial extraction is zero. You are the sole beneficiary. The structural lockout exceeds mere tax ledgers. The Small Wind Certification Council issues mechanical certifications based on rigid engineering parameters. The certification demands thousands of dollars in capital testing fees. Zero corporate entities will fund the certification of a turbine engineered from plumbing hardware. Therefore, zero certified installers will interact with the mechanism. Zero financial institutions will issue capital loans. Zero insurance corporations will underwrite the physical risk on a localized policy. The Distributed Wind Energy Association published a direct metric. Local municipal zoning represents the absolute apex barrier to micro-wind deployment within the United States. The National Renewable Energy Laboratory verified the attrition rate. 50% of all micro-wind structural applicants in specific states encountered total failure. The municipality denied the permit entirely. Alternatively, the human operator collapsed under the friction of legal capital and time. This is categorized as an engineering limitation. It is not an engineering limitation. It is a commercial gatekeeping protocol. It wears the mask of public safety. Acquire an 8-inch PVC polymer pipe. Schedule 40 sewer pipe provides structural necessity. The polymer wall resists aerodynamic deformation. A 2-foot cylinder costs exactly $6. Bisect the cylinder longitudinally. These form the aerodynamic blades. Acquire a permanent magnet direct current motor. A treadmill motor is optimal. 260 volts. 5 amps continuous duty. A 6-inch threaded hub. You acquire this hardware digitally for $30. If unavailable, the physics remain absolute. Any motor generating 1 volt per 25 revolutions per minute executes the function. The mechanical mount demands rigid steel. You require 36 inches of 1-inch square tubing. A floor flung. A pipe nipple. Self-tapping screws. The tail assembly requires exactly 1 square foot of thin sheet metal. A discarded washing machine chassis functions perfectly. Acquire a 30-amp blocking diode. This semiconductor physically stops the battery from discharging backward. It stops the motor from reversing at 0 atmospheric velocity. The total material acquisition cost caps at $30. Salvage the motor and sheet metal. You construct this kinetic device for exactly $10. The manual assembly dictates basic tooling. A jigsaw, a power drill with a 732-inch bit, a 14-inch tap to thread the hub, a steel wrench, wire strippers, a screwdriver. Thermal welding of the joints is unnecessary. Initial structural assembly requires 6 hours. 2 experienced operators complete the sequence in 180 minutes. Polyvinyl chloride structurally degrades under direct ultraviolet radiation. The polymer chains snap. The blades become brittle in 24 months. You must apply a chemical shield. Standard exterior latex paint executes the function. Apply 2 layers. That $5 liquid barrier prevents catastrophic mechanical failure. It extends the timeline from a season to a decade. The elevation apparatus demands steel. Sink a 10-foot galvanized water pipe into a poured concrete footing. Tension steel guy wires at 18-foot vertical intervals. Anchor them to the soil at half the total tower height. Greater elevation escapes localized drag. 10 feet above the roofline generates massive statistical divergence. The chemical storage requires a lead-acid reservoir. One deep-cycle marine battery provides the baseline architecture. It carries a 100 amp-hour capacity rating. You acquire this hardware for $120. Install a 12-volt PVM charge controller. It regulates the chemical saturation. It costs exactly $25 online. The mechanical schematics, material ledgers, and tower manuals exist on open digital servers at zero cost. The Department of Energy maintains parallel schematics on the federal ERE server, designated for academic youth. The physics perfectly translate to residential deployment. Physical limitations govern this hardware. A singular 100-watt mechanism will not support a modern residential structure. It supplements the baseline load. If the objective is total grid separation, the architecture must scale. It requires an array of parallel turbines. Kinetic wind capture and photovoltaic solar arrays must merge. Fluid dynamics are geographically rigid. If structures and biological trees envelop the coordinate zone, the airflow shatters. The turbine is trapped in chaotic turbulence. The voltage output crashes. The Department of Energy explicitly forbids securing kinetic hardware directly to a residential roof. The kinetic resonance shatters the wooden structure. Polymer blades rotating at high RPM represent a kinetic threat. A structural fracture at maximum velocity explodes the geometry. Sharp plastic shrapnel ejects outward radially. Never occupy the aerodynamic vector downwind of an active rotor. Always connect the electrical output to a physical load. Short the motor leads to lock the axis. The mechanism generates 12 volts of direct current. The electrons flow directly into chemical storage. Direct current cannot operate a thermal refrigerator. Alternating current is mechanically required. An electrical inverter must bridge the gap. A pure sine wave inversion unit rated for 1,000 watts costs $150. The capital cost exceeds zero. The final mathematical synthesis is absolute. A PVC Savonius wind turbine dictates a material cost under $20. A residential photovoltaic array dictates a capital cost of $30,000. The polymer turbine induces power in a 7 miles per hour wind. The silicon panels halt thermodynamic transfer after sunset. The turbine architecture possesses a proven operational timeline exceeding 1 century. The lithium-ion cells lose 20% of capacity before a human child completes secondary education. One electrical architecture possesses a federal lobbying wing, a tax credit, and commercial contractors. The alternative architecture relies on discarded plumbing and a digital schematic. The mechanism devoid of federal lobbying can be constructed entirely this weekend. The financial requirement mirrors the acquisition cost of a standardized pizza. You do not require bureaucratic permits for structures under 35 vertical feet. You do not require a certified electrician to wire a 12-volt chemical cell. You do not require administrative authorization to sever a polymer pipe and bolt it to a salvaged motor block. The structural data is free. The localized materials are cheap. The singular barrier preventing localized electron generation is a drive to a hardware distributor and an afternoon inside a concrete garage. The logical sequence demands a decision vector. Assume geographic spacing is optimal. Does the physical sequence prioritize the immediate synthesis of a polymer turbine to offset the load? Or does the capital flow bypass kinetic capture entirely to purchase silicon panels? The subsequent data file demonstrates thermal manipulation. A 0.50 porous clay vessel and a measured displacement of liquid water forces a 20-degree atmospheric temperature drop. It executes this thermal deficit without consuming a single watt of electrical current. That sequence initializes immediately.